In this video, we are going to learn about stocking density in a pond. But this stocking density has to be divided into two parts. The first part we are going to learn, which is going to be in this video, is how to calculate the volume of your pond. How to calculate the volume of your pond. And the second part is to learn how to calculate the stocking density. How to calculate the stocking density. In this video, you are going to do a little bit of work. When I say a little bit of work, you are going to get your paper and pen and get ready, because there is going to be some calculation in this very video. Now, when you are stocking your pond, you should be able to determine the carrying capacity of your pond. The carrying capacity, that is the amount of fish your pond can carry. How do you do this? You should be able to know the volume of the water of your pond. You should be able to know the volume of water in your pond. This is what we call fill point in a pond. When you construct your pond, you know that your pond cannot be filled to the brim. Most especially those that are using concrete pond, rubber pond, you cannot fill it to the brim. So that very point where you fill your water up to is called the filling point. So at that very point, that is where you will take as the height of your pond, the height of your pond. These pond, they come in various shapes. So we are going to look at the rectangular shape, the square shape, and that of the cylinder shape. In this calculation, we are going to use the rectangular and the circular shape for illustration. That is the volume of the rectangular pond or the cylindrical pond. That is the volume. The volume is what will tell us the amount of water your pond can contain, and that will determine the number of fish that your pond can carry. That is what we refer to, or when we are saying the carrying capacity. If this is your first time of coming across our video, please subscribe, click the notification bell. Also, follow us in our Facebook page. Please also share with others so that we can all grow together. So let's dive back into our discussion in this very video. So the first shape that we are going to look at is the rectangular shape. And the volume of rectangle is length times width times height. Length times width times height. That is, the longest side is the length, the shortest side is the width, and the height from the ground to the height of that very pond. So we are going to take some few numbers here in order to calculate our volume of our pond. Let's say the length is 60 centimeter, the width is 40 centimeter, and the height is 1.5 centimeter. So therefore, the volume of the pond now is length times width times height. That is 60 times 40 times 1.5 times 1.5. That will now give us 36,000 cubic centimeter, 36,000 cubic centimeter. You can use your calculator to punch it. And for us to know this very volume, you know we are dealing with liter, not in centimeter. We are dealing with liters. So 1 cubic centimeter, 1 cubic centimeter is equal to 1 milliliter. So 1,000 milliliter is equal to 1 liter. So therefore, 36,000 cubic centimeter is equal to 36,000 milliliter. Because if 1 cubic centimeter is equal to 1 milliliter, it then means that 36,000 cubic centimeter is equal to 36,000 milliliter. So now 1,000 milliliter is equal to 1 liter. So therefore, for you to have the volume in liter now, all you just need to do is to divide that 36,000 milliliter by 1,000 milliliter. So if you divide it like that, if you divide 36,000 milliliter by 1,000 milliliter, you will have 36 liter. So 36 liter is the carrying capacity of that very pond. So if you understand this very carrying capacity, you will not overstock your pond, because overstocking of pond is what leads to overcrowding, and which will eventually lead to high mortality rates. So we are going to look at the cylindrical shape of a pond now. So the volume of a cylindrical shape of a pond is pi r square h, whereby the pi is a constant and the figure is 3.14. And we are going to take our radius to be 60 centimeter, and we are going to take our height to be 25 centimeter. All this figure we are just taking now, we are using it for illustration. But in your own pond, take a measuring tape, go and measure all these various parameters we are talking about, so that you will have an exact volume of your pond. So let's go back. We said that the pi is a constant 3.14 and the radius is 60 centimeter and the height we are taking here is 25 centimeter. So it means that 3.14 times 60 times 250. Sorry, we are taking the height of 250, not 25 centimeter, is 250. So when you when you multiply all this together, you will have 47,100 cubic centimeter. 47,100 cubic centimeter. So as we've already known, we said that 1 cubic centimeter is equal to 1 milliliter. So 1,000 milliliter is equal to 1 liter. So for us to get the amount in liter now, you divide 100 by 1,000. If you do that, you will have 47.1 liter. So the actual carrying capacity of your pond is 47.1 liter. So if you know this very amount now, This will now enable us to calculate the exact amount of fish your pond can carry. So this is just the first part of our video now. So we are going to talk about how to calculate the stocking density of the pond now. Now that we now know the volume of our pond. Because when you understand this very aspect of the volume of your pond, you will not in any way to overstock or to know when and how to